So this will be the second problem. We've got two problems like this in our homework for 13.3. We have two graphs that are given to us. We've worked through this one already, and we're going to work through this graph one, and then I will post it to give you some guidance on how we go through this. So we're given a graph, and we are going to here we go. We're going to find the left Riemann sum. So again, we're going to do rectangles for the given interval. So we're going from negative 1.5 to 5. So before we start doing our drawing, what we need to find out is what the width of each interval is. How wide are those rectangles? So again, we start with the right-hand side of the interval, 0.5. We subtract the left-hand side, which is negative 1.5. And then we divide by the number of intervals. So this becomes a plus. So 0.5 plus 1.5 gives us 2 over 4, which is 1/2, which is 0.5. So this is our delta x is 0.5. So since we're going to start at negative 1.5, that's right here. We're going to go half, which will get us to negative 1. And then we'll go half again, gets us to negative 0.5. We'll go half. And notice we've got 1, 2, 3. We need to go 1, 2, 3, 4. Actually, that gives us our 4. 1, 2, 3, 4. Because this is the end point, this is where we're going to stop. So we don't do one more past that. So we're going to draw at negative 1.5, it comes up to here. So we're going to look at finding the area of this rectangle. See if I can pay attention. Try to draw these lines straight. Okay, and so this first area, we're going to take f of minus 1.5 times the width, which is 0.5, minus 1.5, the area we see here is, or sorry, the height is going to be 10 times 0.5. Okay. Then we look at getting f of negative 1, right? Because that's the next thing here. So that goes from here straight over to the next interval. So that's going to be this rectangle. And we've got to estimate, that's 5, that's 6. I'm going to call it 5.5. So this is 0.5. So f of negative 1 is 5.5. Again, times half. You're going to see all of these will be times a half because that's what our rectangle is down here. The delta x is equal to 0.5. Each of these is 0.5. And we're just doing base times height. That's all that's going on. Now for this next one, we come up to about here. We go straight over. And again, we've got this rectangle here. And we'll go straight up. So we're just making these, and this is just, remember, giving us an estimate. Notice on this side it's an underestimate, that side it's an overestimate. But that's just how it is. Okay, so now what is this value? This is 5, 6, 7, 8. Not quite a half. Let's call it f of minus 0.5 times 0.5. f of minus 0.5 is going to be 8.4. Now we're going to have to estimate as best we can. It's not really quite 0.5. I'm going to call it 0.4. Okay, so that'll give us that rectangle. Notice we've got 3 rectangles so far, and then we go to this point here, this is the function value. This is f of 0 times 0.5. F of 0 is going to be 10, 11, 12, 13. Let's call it 13.2. And again, what we're getting, maybe it's 13.1. I'm going to stick with 13.2. It's going to be good enough. Since we don't have the function, that's about as close as we're going to be able to get. The ones in Alex, not Alex, WebAssign, I get my classes mixed up. The ones in WebAssign are a little bit more accurate. You'll be able to see it's basically either a half or it's a full. So all we need to do is calculate all of these, and what we're getting is the area under the curve from negative 1.5 to 0.5. So let's go ahead and pull up our calculator here. Let's see. And I've got a way to check this. You won't worry about it because I saved the equation that I used to come up with this. But okay, so we're going to 10 times that one. I don't really need to use a calculator to move decimal over 1, so that's going to be 5. 5.5 times 0.5 is, let's just do it because I'm going to probably make some mental error as I go through this. Again, sometimes when we're problem solving, trying to do mental math and problem solve at the same time can oftentimes, at least I find, lead me to errors. So that's why I do like using a calculating machine when we get to all of these more complicated things. And then we're going to have 13.2 times 0.5, 6.6. Add them all together, so 5 plus 2.75 plus 4.2. And remember on the ones, just make sure you write all your work down because you got 5 chances. If I put this in the system, it was a little bit off, I might say, okay, maybe that was 13.3. You could play with it a little bit, but do write down your steps, your work. And so we get an answer of 18.55. And that's the area under the curve, taking into account each of these rectangles. Again, underestimates on this side, a little overestimate here, but this is how we started. If we make smaller and smaller, more and more rectangles, smaller and smaller, we get more and more accurate. Okay. The goal of all of this is to get you to see that when we integrate and we take the first and the last, what we're getting is the area under that curve. And we're going to get techniques that are extremely accurate, and we get to that fundamental theorem of calculus. I won't do the music today, but this is what we're doing. So those are the homeworks. I will then move on to making the video on 13.4 dealing with actually finding these values exactly. So be well, keep up the good progress, practice, do multiple problems, and that's how it becomes more second nature and get you going through those problems a lot quicker. Thanks.